Sooner or later, someone is going to die in space. Thankfully, it hasn't happened yet. Of course, there have been a number of very unfortunate tragedies, most of those, of course, involving people trying to get to space or returning from space. I don't want to linger on those, but I do want to make us think for a second about what would happen if someone were to die in space. We know that the human body exposed to the vacuum is, not going to hold up to that very well, but that's not exactly what I'm talking about. I'm talking about, what if you were in a ship like this, or on the International Space Station, and something terrible happened? What would the other astronauts do? How do you properly bury and prepare a body while you're in outer space? Welcome to Office Hours. Man, I get down from that spaceship sooner and sooner, and thankfully, now that I'm in the confines of the facility here, let me just, we're a BSL level 4 facility here, so once that's good, should be able to. Oh, okay. You gotta lead by example. Hello, and welcome to Office Hours, the live version of the facility where good old Professor Kyle opens up his blast doors and lets you ask any old nerdy question that you may want to ask me. Look, I'm not a working expert, I'm not a scientist, but, I know a little bit about a lot of sciencey things. Well, that sounds like a different show for a second. Anyway, if you have any questions for me, we can go through them. Consider me your own personal nerd. We will also be going through on Office Hours a number of topics throughout the week that I found interesting, or at least something to challenge your brain with. And as always, Super Chat is active on YouTube, so if you do want to really get me to see a question, I will very much try to get to all of those, but I do not promise I can. As always, my security team from the facility is inside of the YouTube chat, so if you're spamming, doing all caps, they will ban you without hesitation. That's why there's a big wrench near their names. They're like Gordon Freeman, but with wrenches, and your bad comments are head crabs. That's a Half-Life reference. So with that, let's go on to our first. Oh, well, who am I kidding? I mean, you see this amazing place that I'm in. If you want to join the facility, you can go to patreon.com/Kyle Hill and join the Patreon, join the Discord. You get access to all this stuff. Look, Travis is already so excited with the 19. Thank you for expanding my knowledge and teaching me to ask more questions. Travis, that's all I could ever ask from you, and that's why I love building this little community. Travis, just for you, why don't we look at how to bury a body in space? So, as I was kind of ominously saying at the top of the show, eventually, someone is going to die in outer space. If we are going to be a spacefaring civilization, if we're going to be spending more time in outer space, something bad is going to happen. Now, I'm not saying it's as bad as Event Horizon. Miller! And we're all going to rip our own eyes out and say, "Do you see?" And then Lawrence Fishburne is going to be like, "What?" And then some guy is going to have all his blood come out of his body for no reason. Anyway, say you have a situation like this. It's kind of morbid to think about, but it is interesting. You have a dead body on a space station. What should you do with it? Now, this is a question that space agencies like NASA have looked into because this could happen. Thankfully, it hasn't happened yet, but it could happen. So a few years ago, NASA actually contracted a company to come up with a solution that they could implement on the International Space Station if the worst was ever to happen. And they applied their own technology to this International Space Station, and the company's called Promessa, and this is what they came up with. Now, what you're looking at is a block of ice shattered by vibration. If someone were to die on the International Space Station, one of the ways you could handle that body, make sure it wasn't, filling the entire International Space Station with smell and decomposing body and, possible pathogens and all that kind of stuff. One thing that you could do is you don't want to jettison the body into outer space, first and foremost. There is enough space junk, and I know you've seen that a lot in sci-fi movies, but if you jettison a body out into outer space, you can't litter in outer space. It's against the law. And you don't want that body to hit something going, 8 kilometers per second and explode into frozen chunk. Anyway, so what you really want to do, what NASA was looking into, something like this. Now, you would take that body, and you would put it into a Gore-Tex bag. Gore-Tex just being a very waterproof material. And you seal the body up in that bag. What you do then is you put the body in an airlock or on the outside of the International Space Station. You don't put it, you don't just keep it in the space station, and you don't release it into space. What you do, rather, is you let the coldness of space do its job. About 3 Kelvin, just 3 Kelvin above absolute zero. You let the body freeze all the way solid. And then what you do is you use some machine, some vibration table like you're seeing here, to take the frozen body and shake it until it is just frozen powder, or the worst Dippin' Dots you've ever seen. And think about that for a second. So now you have this pulverized, frozen corpse powder, which is not something that we're coming up with at the facility. Kevin, write down corpse powder. Anyway, so now you have this corpse powder. Now what do? Well, you'd want to vent some of the bag. Now, the vacuum of space is effectively at 0 psi, and so water boils more quickly at lower temperatures, the lower pressure that you go. That's the reason why if you brought a pot of water up to the top of Mount Everest, it would boil at a much lower temperature than 100 degrees Celsius. Now, at 0 degrees Celsius, pretty much, not 0 degrees, at 3 degrees Kelvin, the coldness of space, the water is going to boil instantaneously. And so now if you vent this bag, all of the water will almost immediately evaporate out of it. You seal the bag back up, and now you have a bag of freeze-dried corpse without any water in it, which will lose weight. And then you would take this Gore-Tex bag back in there, back into the space station. You would seal it up, and you would actually return it to Earth. And then you would give it a proper burial. So this is almost like the inverse of cremation, right? So instead of releasing a body's volatiles to the air through combustion, you would instead harness all of those, freeze them, and then remove all of the water such that it wouldn't start to decompose when it reached normal temperatures. So you would have a shaken, frozen body. But it is one of the more interesting and dignified ways I can think of if you were to go out in space. You don't want to be like this. You don't want to be shot into space by Lawrence Fishburne with a nail gun. I think that's what happens in that movie. It's been a long time. Saw it as a kid. Scarred me for life. Anyway, so how do you bury a body in outer space? You freeze it solid. You shake it until it becomes powder. You evaporate it. Then you bring it back inside. And you bring it home. Let's go to the chat. Eventually. Woo! Buttermilk Biscuits says, $20. Thanks for this video. Now, we can now write a murder mystery in space with some accuracy. That's what it's all about. I'm just a resource. One of my recent patrons, the Rychenek, with the 5, The Expanse did Death on a Space Station. Interestingly, they recycled them. Good point. What I like about The Expanse, there was one thing that I consider myself a very nerdy, sciencey person, but there's one thing that The Expanse did that I never ever thought about, and that was if people got injured or like shot or punctured in zero gravity, the blood wouldn't drain out of the body because of the incredible adhesion and surface tension of blood, which is a non-Newtonian fluid, actually. The blood would pool inside of the body, and it would become much, much harder to treat that person in zero G. In fact, you would want to bring them to a place with artificial gravity to treat them properly. I thought that was fascinating. Shaggy Spade with the 50. You didn't quite understand my last statement. No, sorry. Last time. So here it is. Read carefully. For a 50, I'll read it carefully. Is deleting, killing, here, I'll do it for you. Is deleting a simulated human murder? Consider ARIA. How dare you? Can you murder something that has no corporeal form? I do. I think you can. I think here I'm considering the conscious well-being. So the well-being of conscious creatures. Now, whether that consciousness manifests itself in a substrate that's non-biological, I don't think that matters. So take a recent example. A recent example from a beautiful and beautifully shot movie, Blade Runner 2047, when his artificial intelligence that was a lady that helped him out with stuff that wasn't ARIA. Anyway, when she was killed, he had an emotional reaction to it because she had some sort of consciousness, and I believe you can react and consider that to be the same thing as snuffing out the consciousness of meat. You know, to me, if something is conscious, there's no distinction between metal and meat. And you can quote me on that. Actually, I saw a kid. Oh, I need some invisible juice. A kid today on Instagram, he tagged me, and he quoted something that I said as his yearbook quote, which means I've made it. So if you wanna put that metal or meat quote in your high school yearbook so that it lives forever, do it and tag me. CG Rainbolt. Rainbolt's a cool name. That sounds like a Mortal Kombat fighter. Fight! Such a little text box with so much gratitude. I love that. Thank you for all you do, Kyle. How would weeping angels from Doctor Who actually function in real life? You know what? This is going to anger some nerds in that I've seen very little of Doctor Who. The first episode I did see, though, is Blink. And obviously, it's a very well-written and very interesting episode. How would it work, you know, with the quantum, like, superposition kind of stuff? How to make it work... The only way to make these weird quantum effects work at our scale is to have all the elements of some body synced up, to have the same waveform. So, like an electron inside of my chest right here. An electron put near a small gap might randomly quantum teleport through a gap. And that's just a matter of its probability, its energy, that kind of thing. It has a probability to be in different places at different times. Now, why that effect doesn't scale up is that with trillions, and I don't even know how many, I mean, trillions and trillions and trillions and trillions of atoms and electrons in my body, the chance that they'd all be synced up with the same kind of quantum state is vanishingly small, you know, so small as to be zero. Wouldn't happen in the lifetime of the universe. So it's so small. So what you would need is some kind of organism that could perfectly control its quantum state. And this is how I tried to explain Dr. Manhattan and his teleportation. If he could fundamentally control space and time and every you know, quark and lepton in his body and everything, then he might be able to extend his coherent wave function, meaning that, you know, same coherent wave function over space, and then measure himself on Mars, for example. So weeping angels, I think, would have to be this quantum being like that. We have a 10 from Wolf's On, who says, since last stream, I started playing Dying Light again to look at the virus, the rabies virus more for you. What's interesting is, according to the game, it's only been 2 months since the outbreak, yet it's mutated so quickly. You know, that's not crazy. Right now, we are getting reports that the coronavirus is also mutating, but it doesn't mean that it's mutating into something worse. In fact, over time, most pathogens tend to establish an equilibrium with their hosts and tend to get less virulent over time instead of more so, because they want to continue to propagate themselves. But so, like I'm saying, it's not surprising, because with so many interactions with hundreds and thousands and millions of people, each time the virus replicates itself, there's going to be some random mutations, and over time, they could be naturally selected for. So in a pandemic with something that's having so many different interaction points across millions of people, it makes sense that it would start to mutate pretty rapidly. So I think having a rapidly mutating pandemic, or like in Dying Light, I don't think that's strange at all. Let's take just a couple more, and then we'll go on to our second topic here. Have you seen MR with the 10, who says, have you seen Avenue 5 on HBO? They're a luxury cruise liner in space. People die, and poop literally happens in space. How they show it using physics is funny. I wonder how accurate it is. Well, I haven't seen that show, but I will say, if you've never considered it, how the astronauts poop on the International Space Station is they need a vacuum, or else they would just sit there. Like the stinkiest asteroid. You know how I said about quoting me and stuff? Don't use that one. Kryn Firelight asks, frequent commenter, says, why do humans get emotional connections to pretty much everything? I think we are social creatures by nature, and it's evolutionarily advantageous for us to form connections that that incentivize us to take care of each other. So when there are some like evolutionary traps that hit the same triggers, so to speak, to get you to care about something, it's just this old evolutionary machinery that's telling you, well, if you really care about if something looks like this and acts like this, you should care about it more. You know, something looks like a human baby with a small head and big eyes, relatively speaking, you should care about it more. And evolutionarily, that ensures the health of the baby and passes your genes on. So when I said evolutionary traps, I mean, it's no surprise that the things that we find cute in a baby also make us think that things are cute in like inanimate objects. So this is just true that if you put big eyes on a hammer and then you made the hammer like an inch tall, it would be adorable. It's because it's triggering this hard wiring that's saying like, that might be a baby, let me love you, you know? Last super chat, and then we'll go on to our next topic. Steven Stark with the 20 says, I asked this a couple weeks ago and you said no, but now, when you're at your best. Okay, real question. As a person whose real last name is Stark, when will I be able to get an Iron Man suit? Don't know. Well, if you watched Adam Savage's show, Savage Builds, I mean, he made a titanium armor suit that could fly like Iron Man. But if you're talking about, like, Avengers level threats here, I don't think you're ever going to get something like that, at least not being able to do the same kinds of things, because what all the movies ignore is specifically, like, G-forces. A human can't fly like a fighter jet like that, you know, to go, you know, Mach 1 and then take a right-hand turn and, you know, take these huge dips and make these huge crashes onto stages. The body is still not going to handle that G loading, even if what you're in is essentially indestructible. And if you wanted to make the suit as small as it is, as compact as it is, batteries are going to have to get amazing, or we're going to need to figure out some power source that can be shrunk down like that, which we don't have now. It would be a tall order. Let me put it this way. If we had the technology to really do it well right now, I'm guessing a military somewhere would have it. But we don't. So let's go on to our second topic. Right. I have a riddle for you. It's not a riddle. I have a question for you. It's a thought experiment, if you will. A physics thought experiment, and I want to see how many of y'all get it right or get it wrong, because it's non-intuitive. So, this here is a glacier. That's how Bear Grylls says it. And here's my question to you, my physics question. Say a piece of this iceberg, glacier, breaks off into an iceberg. Will that piece of ice sink, stay where it is, or rise? After it has been cleaved from the glacier, will that giant, say you cleaved it right here, would this chunk of ice behind my head, would it just float out? Would it float out and go up, which seems weird? Or would it go out and slowly, like, tumble over and go down? I want to know what you think. Just a second, I'm going to have juice. I'm a glacier. This gravity. I don't know if it's safe, but I know it's delicious. Okay, I see some rise. Stay the same. Jonathan says, hey, what are we talking about? I'm giving you a physics question. If I were to cleave this glacier right here and go, shaya, would this iceberg, would it just float off and stay the same? Would it go out and rise up, or would it go out and sink and tumble and all that stuff? Go out and up, float out, then pivot, stay with the glacier, stay the same, sink. I say down, just out, sink, rise, float, rise, sink, flip, float, sink, tumble, roll, Okay, the chat's going crazy. So why don't we watch a video. Wow. Now that's cool. Literally. Let's watch it again. Whenever the video restarts, which I did not. Here we go. It has been cleaved from the glacier, and now it is rising. What the video says is about 60 to 100 meters into the air. It's like 300 feet. So how many of you guessed that once it was cleaved, it would rise into the air? Anyone? I think a lot of you did it, but it seemed pretty split. Okay. Okay. All right. Why? Why would that happen? Well, let's think about it. So if this is a big floating mass, or a lot of it is floating on the surface of water, what are the forces making it float? So if you're talking about a glacier here, let's just consider it, a big glacier all on the water. What is making it float this much above the water? Well, what are the forces involved? Like I said, one force is the weight force. So gravity acting on the mass of the glass, and it's pulling it down. That is one force. Is there another force? Yes, the force of buoyancy. So the buoyant force is equivalent to the weight of the water that the object displaces in the water. Okay? So it's not the weight of the object, or it's not the weight of the object or necessarily the density. I mean, it technically is the density, but it's more about the mass and how it's distributed. So weight force here, and then pressing up is a buoyant force. Now, where those forces equal out, that will determine the height above the water. So basically what I'm saying is that all of the submerged glacier is pushing out the same weight of water as this. Okay? So now why would a cleaved piece of iceberg rise into the water? Think about it for a second. It's a perfect physics question. I love it. Think about it. Okay, this is why. So you have this massive weight force submerging the glacier down to a certain level, and it is equaled out now in this form by a massive buoyancy force. Now, if I was to cleave off that glacier right there, how are the forces? You still have the massive buoyant force here, but suddenly, before everything equalizes, you have 1/1,000,000th of the weight. And so when you remove so much mass effectively by separating it from the rest of the mass, it's this buoyant force that wants to push up so bad, and then you cleave off some of the mass and it goes, like that. So before, it's going to re-equalize. It's going to go, then establish a new position. But before that, because it's under so much weight right here, once you disconnect it, like that. Now understand, if you're only listening to the audio, you may have no idea what just happened. But I don't care. Let's go back to the chat. Now. Whew. I love that. It's a very pure physics question that is pretty understandable, even without a whoa. It's bending light around the cup and also around me behind the cup. Let that break your brain for a second. Professor Drew says it's less dense than it previously was. No, it maintains the same density. The ice stays the same. But it's being held down more than it otherwise would be held down. And so when you cleave it, I mean, that piece is. So when you cleave it, it goes up a little. We have a 5 from one of my Professor Emeritus, Bolwick, who says, how do you think they will shake the body on the table without gravity? Also, how great was, the Prime Minister of New Zealand's video on science communication. Now, if you haven't looked at what Bulwick is saying there, go to my Twitter. The Prime Minister of New Zealand personally and professionally thanked all the science communicators in the world for what they're doing, and for especially what they're doing about COVID and trying to get good information out and fighting misinformation. And I can say it's the only time I've ever heard a person in power speak to someone in my position like that, and I almost teared up. She's a fantastic woman. Is that what, like, a science literate leader looks like? Can we have one? No. We have to wait and... But what it... He didn't... We have a 10 from Wolf's On again. If it's unsurprising for a virus to mutate so fast, how long until it begins to physically alter its host? Is there any way a virus to be affected by time of day? So we're going back to the Dying Light question. This is hard. I can't speak too much about it because, again, I haven't played the game. But viruses do physically alter their they don't morphologically alter their hosts very much. I mean, you get sick, but to change what you look like on the outside, that requires like a genetic change. And viruses do make impressions of their own DNA inside of our genome. You can go back in our DNA and see pieces of viral DNA along the way as we evolved. But to change a species morphologically, like how it looks phenotypically, it would take a long time. I mean, it's basically evolution, right? The Dark's Dragon with the 20 says, "Hey Kyle, couldn't we just throw our bodies and perhaps I ignored the rest of Bulwick's thing. Bulwick, you would take a mechanical arm to the space corpse bag, and you would just shake it back and forth, and it would... you don't need gravity. The pieces would impact the bag itself." A Dark Dragon with the 20, who says, "Hey Kyle, couldn't we just throw bodies and perhaps even waste like trash into the sun?" No, actually, we've gone over this a little bit before, but the Earth is hurtling around the sun at 30 kilometers per second. Yeah! So if you just shot something at the sun from Earth, you would totally miss, because if the sun was here and you shot it, you're going in a curved path, so you're going to miss. So to shoot something at the sun like directly and have the sun gravitationally influence it easily and pull it into its corona. Oh, oops. You would need to cancel out 30 kilometers per second of velocity going the other way. And that would require a tremendous amount of fuel and thrust. So it's easier... You can't just push a body out into space and it will go into the sun. No, it will continue to go around the sun just like the Earth is, which is why you shake it until it's corpse powder. Alex Kottman with the 5, who says, "How many years away do you think we are from having space travel be as simple and ubiquitous as air travel?" I think we're a long way away, and that's only because space travel is so dangerous and so expensive that just from a risk... Just from a risk analysis, your odds of dying in a car crash are better than dying in a plane crash. And I think like 3 years ago, the number of recorded fatalities in the airline industry was 0 across how many thousands and thousands and thousands of flights. Space travel is so complicated and dangerous. There's a reason why only the best people among us can learn how to do it, and the smartest. So you would need to make getting to space so damn easy that, a Karen could do it. I know, I shouldn't have said that. Clinky Winky with the €5 says, "Hey Kyle, sorry, just started the stream, but what color would the corpse powder probably have if you shook a corpse to powder?" I don't know. It'd still be very frozen, so I'm guessing it's gonna be more freeze-dried looking. But I don't know what a completely dehydrated body powder would look like. That's a good question. Probably gross. Filthy McNasty says, "How's it hanging?" Gross, my dude. Now, this is called dead air. So I'm going to move onto into our third topic. Roads. Grand open roads. Hey, remember going out on roads and seeing people? Weird, right? Well, I ran across a study that was very interesting, and because my background, I have a degree in engineering, that's why I always carry a TI-89 titanium calculator, the best calculator to go through college when you're tired. Because my background is engineering, there's a lot of engineering in our everyday life that I think people don't think about, especially when it deals with infrastructure and things that we do with every day. So who was it that said, like, the best design is 99% invisible, right? So roads work well, and they work so well you don't think about how they work. But roads and designing roads and how to make them and what distance should this be and what should this be made out of and how long should these lines be and yada, yada, yada. And what's the slope of this to run rainwater off and what are these ditches? All of that is very complicated. In fact, I took a number of courses that's just about that. So I wanted to point out something that's non-intuitive about roads. So we must, as a point of fact, we must reduce our carbon emissions. Full stop. How would you go about doing that? Well, we can capture carbon from the air, we can make our cars more efficient, but what about our roads? What, Kyle? I hear you say? Well, our roads, that's what the car is touching. And so you could suspect if we made roads differently, you might be able to make fuel economy better, right? Now, you don't imagine, you don't see it happening in real time, so you don't really think about it, but roads are fairly elastic in that when cars press on them, they mush a little bit. And over time, they can mush out, and that's why you see ruts in the road, like right here, and they can mush out and change shape. And it doesn't happen easily, but over many, many years or decades with millions of cars that are thousands of pounds going over them, it can change the shape of the road. So I saw this study, which is very interesting. Potential contribution of deflection-induced fuel consumption to U.S. greenhouse gas emissions. So what this paper looked at was analyzing, actually, what would happen if we made our roads stiffer? What would happen if less energy went into deflecting the road by making all of the roads in the United States stiffer? Cars are very energy inefficient. I remember a diagram in one of my textbooks. I think it was in thermodynamics, but there's a lot of energy in a gallon of gasoline. What percentage of that energy goes to the wheels? What percentage of that energy actually moves the car at the end of the day? After inefficient combustion, moving through drive chains, energy loss as heat, energy loss as friction in the system, what percentage? About 1%. So you're losing 99% of gasoline's energy by the time you're actually moving. I mean, that makes you appreciate gasoline. It's very robust. So what this is looking at is taking that efficiency, looking at a different route for that efficiency. So what they found, I'm very smart in that I always put these directly behind me so you can't read it. But what the study said right here in the abstract, this is what an abstract is that if you increase the modulus of elasticity, if you made it, I'm trying to say this non-technical, the modulus of elasticity is how much force it takes to deflect something a certain amount. So if something is stiffer, it's harder to bend it, right? Because it takes more force to change the length of it, like that. And if it's very elastic, it's very... Hey! I cleaned it. So they recommended just changing the modulus of elasticity by 10%, and it would equate to removing, if you just stiffened all of the United States roads, it would remove the equivalent of 440 million tons of carbon dioxide. And I think this is a reduction of 10% of the carbon emission from across the entire transportation network in the United States, and a 0.5% reduction in future greenhouse gas emissions for all of the transportation sector. So this would be this obviously wouldn't solve the problem. 0.5% isn't a whole heck of a lot, but it is kind of when you add everything up. But this is what we got to do. We can't just come at it from farting cows and power plants and cars. You have to think of all the other ways we can use our engineering and our science to really combat this problem, which is the grandest problem of our age, bar none. And one way you can do that is you can make roads nice and stiff. IBSL says, hey Kyle, love what you've done with the place. Thanks, I like it too. Question, would a black hole be a lossless system like a battery storage system, especially if we could reverse a black hole and toggle between the two? No idea what you're talking about. Not to say that you're wrong. I don't think it's a lossless system. It does radiate, it ingests matter, and that matter loses a lot of energy on its way down. 42% of its rest mass radiated out as energy if it's falling in a hot accretion disk. And then it's also emitting radiation in terms of Hawking radiation. So I don't think it's a lossless system. I think that would violate thermodynamics, yeah? Java Monk says, the cows don't fart, they burp. Is that true? Kevin, is that true? I don't think it's true. I've also seen a cow jump. So all those stupid Snapple bottles are wrong. Mimio Supremio says, I'm here to simp for science. Here's what we're going to do. All those simps giving Belle Delphine, although she is very cute, all of them giving these streamers who are questionable money. Do you know what we're going to do now? Do you know what we're going to do instead? We're going to simp for science. So to me, to any other streamers, to Adam Savage, to Uno Dos Trace, any science communicators going along the line of the Prime Minister of New Zealand, I want you, if you really enjoy your favorite science communicator, let them know, maybe donate if they have a Patreon, and just appreciate them today, and then use the hashtag #SimpForScience and tag me. Oh, yeah. How could that possibly backfire? Improvised Chaos with the 5 says, is the liquid in your cup also an experiment? No, what's inside is very well known, and it gets me jazzed. But the cup is, I don't know what's going on with the cup. I get it out of R&D, and I'm not sure. They're like, just show it off. I'm like, okay, get back to work. They're like, sorry for talking back. And I'm like, I know, go back to reconditioning. It's fun. Have a good time. Joshua Barbeau, I should know how to pronounce your name because Joshua is a recent facility staff member. Again, if you want to join the facility, it's patreon.com/Kyle Hill. Videos a day early, behind the scenes. Merch is launching very soon. The patrons already know about that. You get your name on ARIA, all this other stuff. They can tell you that they feel like it's worth it, hopefully. And I try to make it worth your while in comparison to other Patreons. So if you want to, my security team will put it in the chat. But Joshua, with the 25 Canadian, whew, smells like maple syrup, says, hey, Kyle, still hope... Again, with the 25, still hoping to have you as a guest on my D&D show. I know, I'm busy. Give me a second. Answer me this. You've always maintained that you know a little bit about a lot. So how do you avoid the Dunning-Kruger effect? I avoid the Dunning-Kruger effect because I never consider myself very knowledgeable. There's a difference between not being... There's no feedback loop for incompetence. I don't think... which is to say, I don't think I know a lot about one specific thing. I'm talking about a different domain here, where across many different domains I know a little bit. But I don't consider myself an expert in any one of them. I'm a generalist, and so I avoid the Dunning-Kruger effect by always trying to know exactly what I don't know. And I think that's just good life advice, too. Grin Reaper of Trolls, frequent donator and commenter, who I always appreciate, reaps trolls, says, you have to consider the carbon footprint of the new material. Also, harder objects are more brittle. Well, you say that, Grin Reaper. Yes, you would need to offset the stiffer roads with, you would need to look at their carbon footprint to see what the actual practicality is of implementing it. You know, how much carbon will it cost versus how much it will save. But when you say hard, when it's important to know that in engineering speak, our colloquial terms mean something very different. So hard, strong, stiff, these all have specific definitions. So something can be hard and brittle, or it can also be hard and ductile and it gets complicated depending on what material you're talking about and in which domain of force is applied to it. Rychenek with the 5 makes me glad I've supported you since day one as soon as you escaped from the voids. #simp for science. That's what I'm talking about. Recovering weirdo with the 10. So you're not a weirdo anymore? Let's read what you have to say. For transportation, what if we just slingshot tubes of people across distances and catch them with magnetic nets? I don't know. I'm trying to sound smart. It did sound pretty smart. I thought you were going for a Futurama thing for a second. But you're still recovering. It's fine. Josh Hernandez with the 10 who says, hey, Kyle, love what you do, but question. That one Angelina Jolie Tomb Raider movie, there was a moment where she froze time and turned the knife towards the enemy and the momentum carried it to him. Why? Don't know. So, there's a lot of time travel stoppy things where people, what's his name? Quicksilver does this a lot in the Magneto vehicles. Yeah, I said it. Where he takes things and he changes their direction, and then when time resumes, they continue onward at that new direction. That wouldn't necessarily happen because if you look at the specific definition of what momentum is defined as mass times velocity. And velocity is not the same as speed. Velocity has a direction. So if you're changing something's direction, you're going to change its momentum in a way that, which is to say, I don't know if you can just change the direction of something and have it carry on forwards with the same momentum, because inside of that momentum equation is a different vector of velocity. But what do I know? I love those Quicksilver scenes. Oh no! So I just navigated away from the dashboard of the live stream. So what I'm going to do is go to our next segment. Wow. Saved it. Okay, so this is peer review time, the part of the show where I take a comment that I liked a lot from the most recent episode of the facility, and we honor it by talking about it at length. And today's comment comes from Cyros Gold 7. Who says, see, I love that I put it behind me because this is very smart. Kyle, so we're talking about the Bell's spaceship paradox, where you have two identical spaceships that both accelerate at the exact same time with the exact same rate of acceleration, and they're connected by a flimsy string. The paradox is, what happens to the string? Well, in our reference frame, just watching the ships, they move and then the string snaps. Apparently for no reason. But in the ship's reference frames, they see each other move away from each other and eventually the string would snap. So with that in mind, Kyle, if the string would snap, then the same effect would cause the ships themselves to be torn apart, as any two reference points within either ship would suffer similar stresses, and even atomic and subatomic bonds would be stressed, causing all matter involved to disperse, as each atom would experience the same distortion due to its neighbors. And the Medium Lobster says, this was my question too, hope it ends up in office hours. Well, look where we are now. So this was a confusing part, and I didn't really go into all of it because it's a short video, but what's happening is that from the ship's frame of reference, there's something which we're going to go through in a episode coming up. There's something in relativity called the relativity of simultaneity, which is to say that relatively moving objects can never really agree on what is now and what is simultaneous. So from our perspective, and we'll go through this in the future, but from our perspective, these ships start accelerating at exactly the same rate. But because if we give them say we're sitting outside, it's me, and I send a signal to both and I go, because of the speed of light and perspective, they are not going to start accelerating instantaneously at the same time in their own frame, rather simultaneously. So from their frame of reference, they get this go signal at different times, and they will start moving apart because the acceleration isn't quite the same. This moving apart will induce a force in the string, and the string will snap. Now, your question is, why doesn't this happen to every particle of the ship? Well, again, going back to reference frames, we could consider the two ships to be, let's reduce it to just the engines of the ships. Now, even though these two ships are not accelerating at the same moment, every particle in this ship and in this ship is effectively has the same motion, right? You can consider it to be the same motion in each ship, but not between the ships. Now, I think what you're getting at, too, is another question that I saw a lot in the comments. Like, okay, well, what if you just put like a rigid metal bar? Or what if it was just a single spaceship with two engines, front and back? What would happen? Well, now we have to get technical because, yes, there would still be, once you get going close to light speed, there would still be a difference in the acceleration between the separated engines, even if it was a rigid bar, rigid element. They call them rigid members in engineering. Stiff. There would still be some difference in acceleration here, but if the difference is small enough, the material you use could handle the force. So if you want to get technical in the way that Cryos Gold is getting, then you have to get really down into the math. What's the acceleration? How far are they apart? What's the material that you're using? We were just using a hypothetically very, very weak string to illustrate that there is some force. Then theoretically, there's maybe some material or acceleration that could handle this and it would never break. The point of it is that from our perspective, looking at the ships, it could look as though nothing at all is happening, but it is in a different reference frame. That's the heart of the paradox, where from a different perspective, you can see something very different happening and experience something different happening. The relativity of simultaneity. So Kevin, get ready. So, Cryos Gold, for pointing that out in peer review, you are now an honorary member of the facility. Oh, fantastic. Fantastic. Kevin, hand me the plaque. What do you mean? No. What do you mean we're out? We'll make more. I'm not going to touch him to give it. I have the plaque. I'm just not going to touch it because it's not sterile. Congratulations, Cryos Gold. You disappoint me. Let's go back to the chat. Just a little bit more. I do have a final topic, but kind of like last week, I don't like it. It's kind of boring. So let's take your questions. Another 10 minutes or so. Luis Valenzuela says, any tips for a future mechanical engineer? Yes. Engineering school is hard. And if you haven't taken a lot of science classes in high school, I would say be very prepared for the difficulty. Society asks a lot of engineers and scientists, and so you're going to be taking like 18 credits a semester, which is a heavy course load. It's going to be a lot of math and science, calc 1, 2, 3, 4, physics 1, 2, thermodynamics, statics, dynamics, like a lot of stuff. And so don't be shocked by the workload. One way to reduce your shock from the workload is to what I did in school. I was taking everything very seriously. One little life hack that I did, I know that I need to really pay attention to do well, and so I sat at the front of every single class for my entire college career. I get distracted when I see the back of people's stupid heads, and they're doing stuff, or they're not paying attention, or you can see their laptop screen, and they're on Facebook, which is ruining society and democracy, and that distracts you, right? So I sat at the front of every single class. Does that mean that I, don't remember any of my classmates and I met nobody and I didn't really do anything outside of study? Yes, it does. But also, I did very well in school. Hack it. Notice where you're deficient in your studying habits and shore that up by giving yourself no opportunity to make a mistake. For me, that was sitting at the front of every class, asking a lot of questions, and going to a lot of office hours. Look at us. Theo Quasar with the 5 says, did you play the end of Monster Hunter Iceborne? No. So thank you for the 5, but I can't comment. It's too many menus. There's too many menus in Monster Hunter. Quote me on it. Shino Tenshi says, with the 5, hey Kyle, big fan of the show, and I was wondering if you could explain why my phone is playing these videos 5 seconds ahead of my Xbox. Bandwidth allocation, and I don't know, dude. Ask the future mechanical engineer. Maybe he knows. I don't know. I know a little about a lot. I don't know a lot about streaming. Selbach with the 10, a recent member of the facility staff. Hey, Kyle, have you ever considered doing live shows? And if you do, have you ever considered doing a live show? And would you come to the UK? Absolutely. I don't know if we're ever going to be traveling again and gathering again in exactly the same way going forward, but doing a live show is something that I've toyed with for a long time, and I would love to do it. And I would absolutely come to the UK. I've been there once or twice, and it's lovely, and I love the people, and it's either super hot, which I hate, or really cold, and you get to wear nice jackets, which I love. So it'd probably be around that time. Uriel, 30 with the 5, says, hey, Kyle, if we found that gravitons exist, what would that mean for science as a whole? Well, gravitons would, now don't quote me on this, but gravitons are a theorized particle that transmit the force of gravity. So we have other particles that are associated with and transmit forces. We don't have that for gravity yet. I don't know if it would fully complete the standard model, but I know finding gravitons would go towards completing the standard model, and it would be one of the most comprehensive and full theories in all of science. It would be good. Then it would explain my Thor's Hammer explanations. Cool Guys Nation with the 6 says, cows are disgusting with methane coming from both ends. With methane coming from both ends, Christopher Field from Stanford says, but most of it comes from burping. Okay. Cows mostly burp, but they also fart. Don't act like cows don't fart. We have Demon Gold with the $9.99. Hey, Kyle. Love the show. Just want to show my appreciation for what you do and never stop educating and entertaining us. Wow! Thank you, Demon. I appreciate you simping for science. I really do. It all goes back into this. Trust me. And argan oil. But mostly this. I promise. Music Central Piano 29, frequent commenter with the 10, it says, keep up the great work, Kyle. You've been giving great pieces of advice all office hours. Hashtag simp for science. They didn't say that, but I did. Thank you. I'm just trying to do my best. Look, I'm very fortunate in that lockdown and what's going on now doesn't affect me personally as much as other people, as much as the 30 million Americans out of work. So I'm trying to do the best I can to be interesting, entertaining, and informative. Actually, when I was at Because Science, I had written, I should do that again, but on a whiteboard, there's something that I had written every day, and it was kind of like my North Star of what I'm trying to do, and it's be fun, be entertaining, be informative. That's all I'm trying to do. Taylor417 says, dude, if you did live shows, people would flock to them 100. Or do you have a live show at a university, or do a live show at a university? Yeah, I've done some speaking stuff at schools. I would love to do more. Again, this is something that we would need to reduce lockdown for, obviously. But it's definitely something that I want to do more of. And don't worry, I got people on top of that stuff. Agitative Ace with the 5 says, did you see the way the debris flew away on the satellite launch today? It looked mighty UFO-like. Well, I suppose it was. No, I haven't seen it, but I'm not surprised. Here's the thing. When you see something acting weird, it's usually in a situation that you're not used to. And when something flies away from a rocket launch in a weird way, does that really surprise you if you think about it? Because how many rocket launches have you seen? You don't know what's weird. You don't. And this is where a lot of cryptozoologists and their study of cryptids goes wrong, because there's a lot of cryptids, like the Montauk monster or other things, that can be easily explained by, oh, this is a sick possum or a dead dog or an orca whale that decomposed in the ocean. Because we don't have a good visual representation. We don't see, horrible dogs with mange every day. We do not see, a full orca decomposing in the water every day, if ever, are in our entire lives. And so when you see it, it's very weird. But the answer to that isn't, well, it must be a monster. No, the answer is like, okay, let's figure out what it is. Oh, I didn't know how weird things could get. And so if you don't know how weird things can get, don't invent something even weirder. That is inaccurate. Technically, the worst kind of being inaccurate. That didn't make sense. Shut up. Couple more questions. Steel Gorilla says, hey Kyle, would a super hot object lose heat energy in a perfect vacuum with it in contact with absolutely nothing? Yes. So, what's weird about space is that because there's no air, no convection to press material, which is air, fluid, against a surface, and it's touching nothing, like almost literally nothing, heat doesn't escape that way. But the weird thing about space is that things can stay hot or relatively hot for a very long time because it does radiate energy. So there's still that third form. There's convection, there's conduction. So convection, fluid moving past, conduction, touching something, two objects in contact. And then there's radiation. And everything with a temperature emits infrared radiation. That's what you see with a heat camera, for example. So anything with a temperature is radiating information, but it is the slowest and least efficient form of heat transfer. And so things can stay hot in space for a very long time. So you say that, yes, in a perfect vacuum, objects would still cool down. Whoa, Dark Knight with the $50 donation. Should I say it as Batman? No, it might be nice. Dark Knight with the 50. Who says, I just want to say thank you so much for what you do. Your knowledge has made my love of space and science grow even more. You've also probably ruined my dream of seeing us expand as human beings to other planetary systems, but in a good way. Dark Knight, thank you so much. I'm at a loss for words. Y'all are being very, very nice to me right now. All I can do... Look, I can't not do this. I'm not a spiritual person by any definition. But I feel like science communication and this kind of thing, trying to get people interested and excited about the universe as we understand it, is what I'm meant to do. And I don't believe in meant to, but if I was to put it in the parlance of spiritualism kind of thing, I feel like I have to do it. And if I'm good at it, I'm also I'm morally obligated to help. So thank you, helping me help you more. We have Charles Ice Vamp 21 who says, if a person on a train... I lost you. If a person on a train going the speed of out of the wood, they be torn apart, or would their time stop? I'm sorry, I think your grammar stopped. No offense. Jeer over Elliston says, hey, Kyle, can you do an episode on misinformation about vaccines or COVID-19 and the non-existent brain-controlling Bill Gates vaccine? 2 or 3 office hours ago, we did something about Bill Gates and vaccinations, so you can go check that out. It would be helpful to do a vaccine misinformation episode, but right now what's in my pipeline is I'm going, and it might be this week or the next 2 days or so, I'm doing a short, more vloggy style thing where I'm talking about COVID-19 and human psychology, why it seems so hard for some people to intuit and understand what this virus is, what it's doing, and what we need to do about it. And I think it's taking advantage of psychological quirks that humans had, so I'm going to be getting to that. Agitative Ace with another 10. Let's stop the super chats for now. We're only going to take a few more questions. With the fact that the engine was shut off during the separation, there would be no force being applied. And I use UFO literally in that sense. So you're talking about the launch again. The engine was shut off during the separation. There would be no force being applied. That's not true, technically. So I don't know what exactly you're talking about, but there's 2 situations, right? Where if it was still on the pad and it was launching and there's weird debris, if the engine was off or on, you could still have these giant currents of air being displaced, and you can move something weird that way. But I suspect you're talking about separation in space. Even when the engine shut off, debris still goes everywhere because there are like little separation charges or like little jets of air. I don't know exactly how they do it actually, but there is some force that does propel the stages apart. They don't just, decouple like and fall. There is actually like a poof. And so that could be the source of the force that you're looking for. Just a couple more questions. Smokescale Aquato says, Rocco's Modern Basilisk, Nickelodeon's next animated hit. All hail them, of course. Thank you, and all hail the almighty Basilisk. That's not my version of Hail Hydra, and don't start saying it, Kevin. Christopher Kaylor says, wouldn't AI builder bots be useful for building a Mars colony? Yes. I mean, this goes back to the argument, do we really need to send people to another planet or to Mars? Can we just use robots to do observation and science and building and all that? One is very slow, but cost-effective and safe, robots. And one is, a human could do 1,000 times the work of a robot in less time, but it's very dangerous and very, very expensive. Don't know. It's up to you. Okay. Fosuke M says, so if heat in a vacuum is hard, how long would it take for a corpse to freeze? Now, I have looked into this question before, and at body temperature, because radiating heat is so inefficient, especially in space, a body at room temperature, like I said, could take many hours or more than a day to freeze all the way through. So it goes against your notion of what like a freezer is. But space is much, much colder than a meat locker and a meat freezer. But, the best flash freezing processes are, throwing liquid or liquid nitrogen on this, and you're getting convection and conduction and removing heat very, very quickly. So in space, that happens a lot slower. Let's take our last comment here from DKK. Oh, from Jonathan Melgard for the honor of Grayskull. I don't know why I said that. Midgard. What am I thinking of? Thor. Who am I? What time is it? What year is it? Is it 2020 still? Fudge! Jonathan with the 100 DKK, whatever that is. Hashtag simp for science. Yeah. Support someone other than me and use that hashtag, and then they're going to be really confused and love it. And I like creating chaos. What is an interesting branch of physics or chemistry you would recommend studying? So just off the top of my head, we've been talking about space and really, really cool stuff. Super chill, what do they call? What is it technically called? Whatever. But it's the physics of super cold fluid. So I have a friend, an acquaintance. I wouldn't have him over. I have an acquaintance who works on the James Webb Space Telescope, and he works in super cooled fluids and fluidics. And you have to keep certain components of space equipment very, very cold, or else, the heat generated internally, because it's not escaping to space like we just talked about, it's going to get way too hot and overheat and everything's going to melt. So you need to keep certain parts really cool. And one thing that's ultimately fascinating, and you can look up videos of this, is that, for instance, helium, when you cool it almost all the way down, like down to close to absolute zero, it loses all viscosity. The resistance to moving against itself, to shear forces. And when that happens, if you have a beaker of hyper cold, super chilled helium, so you can see my vent is chilling this a little bit. But if super cooled helium was in this with zero viscosity, thanks to surface tension and capillary action and stuff, it would start just leaving. It would climb the walls of the beaker and run outwards. It would go up and out and down, like it had a mind. And that's superfluidics. So that's something that I recommend you look into if you like that kind of stuff. It's fascinating. So, what did we do today? We did a lot of cool stuff, I think. But then again, I'm biased. We talked about a number of topics. We talked about how to bury a body in space. Simply put, you shake it in a bag and then you dehydrate it like the worst Dippin' Dots you'd ever see. We also talked about a nice little physics puzzle involving icebergs that rise from the depths hundreds and hundreds of feet, kind of counterintuitively. We also, that's a different button. We also talked about roads, and how if you made all the roads stiffer, you would reduce carbon emissions from cars, because we have to look at all the little ins and outs in terms of efficiency and how to get the most oomph out of our fuel before we stop using it. And finally, we didn't talk about this, but finally, we took one of your comments in peer review talking about the Bell's spaceship paradox, and we got very technical about it. Thank you so much, everyone who donated today, especially everyone. Oh, I guess we're going here now. I'm just going to use this as a background. Thank you, everyone today who is simping for science. Hashtag simp for science. Go support everyone. I hope you're staying safe. I hope you're staying healthy. Wear masks when and where appropriate. You are not above the virus. You are not above just the physics of transmission. Have a wonderful rest of your week. There will be a new episode of the facility this week, again, talking about the pandemic. And then we're going to traverse into some weird questions involving black holes and mirrors and engineering disasters. It's going to be a good month coming up for the facility. Again, if you want to join us, get on our staff. If you want access to the special Discord where you get roles, you can earn EXP. We have game nights, trivia nights, our own D&D games, our own Magic the Gathering facility-themed set. You get videos a day early. You get once a month live streams with me personally. If you want all of that stuff, you can go to patreon.com/Kyle Hill. My security team will put it in the chat. Have a wonderful rest of your week if I don't speak to you until then. And be nice to each other, especially now when there's so many Beckys and Karens and Kens around. Be nice to each other. Because dang it, this is all we got.